Good afternoon. We are doing our last objective of Unit 1 today. This is CO6. I can find the least common multiple of a set of numbers. So a couple of objectives ago, we did the greatest common factor. Very different than least common multiple. Greatest common factor, we were breaking it down to what its factor buddies were. What numbers do we multiply together to get to it? Now we're at least common multiple. What can we multiply up to? Okay, so multiples, our numbers are getting bigger than the numbers you're given. Factors are smaller than the numbers you're given. Super, super easy to confuse those two. So we have that test next week. We have to remember what greatest common factor and what's the least common multiple. So a multiple are numbers, really, I don't know why it's giving me the different pen today, it's throwing me off. So numbers, a given number can go into so it's skip counting, right? Multiples of 3, 6, 9, 12. Multiples of 4, 4, 8, 12, 16, 20. So you're multiplying up. Those are your multiples. You're getting bigger. You're going up. You start with 4 and you're skip counting by 4. So remember how factors and multiples differ, can be tricky. Here's a comparison. Factors of 12, that's when we break our 12 down. So those factors could be 1, 2, 3, 4, 6, and 12. Because we can multiply numbers together to get up to 12. That's the factors. So factors are when you break the number down. But now let's look at multiples of 12. 12 times 1 is 12, 12 times 2 is 24, 12 times 3 is 36, 12 times 4 is 48, 12 times 5 is 60. So those are the multiples. We're skip counting by 12s. So multiples always get bigger, factors always get smaller. So factors of 12 are going to be 12 or smaller. Multiples of 12 are going to be 12 or bigger. So today we're going to be doing least common multiple. So finding the least common multiple using the MCL method. So M, we're going to list all of the multiples. So let's list multiples of 6. Well, we're not going to list all of them. Why wouldn't we list all of the multiples?
They go forever.
They go on forever. So I like to list up to 10, because I can do that a little bit quicker. So 6 times 1, 6 times 2, times 3, times 4, times 5, times 6, times 7, 8, 9, and 10. Okay, so I list my multiples out in order. I usually do 10 and see how we're doing. So I'm going to do the same thing. I did it for 6. Now I'm going to do it for 10, because those are the two numbers that we were given. So 10 times 1, 10 times 2, times 3, times 4, times 5, times 6, 7, 8, 9, and 10. So that you're listing their multiples. So this is like when we did the listing method with our factors. Now we need to find what multiples they have in common. We're going to circle multiples in common. So what numbers do we see in both of our lists? Emily, what's one of them? We see a 30s. What else do we see that they have in common? Grace? 60. Okay, so common multiples are 30 and 60. Now the L. What's the least of the common multiples? Henry? 30. So our least common multiple of 6 and 10 is 30. Just like when we did the listing method with the greatest common factors, it can be easy to miss or make a mistake with when you're writing your multiples up. You might miss one of the multiples, or you might skip count wrong, all right, and get off track. So it's easy to make those little mistakes. Sometimes the least common multiple is a really big number, and we'd have to be listing a whole lot of multiples. Because if I didn't find a multiple in that first 10, would I just say, oh, they don't share any number in common? No, I would have to list another 10. Maybe their least common multiple is in the next 10, or in the next 10. It's hard when we're not sure right away what that least common multiple is. Sometimes we just know it because it's a small number and we know our math facts and we can find it on our own. But if you don't know what the least common multiple is, we have to use one of our methods. So I'm going to erase this, and we're going to see that table method that we used with our greatest common factor. We're going to see how it's similar but a little bit different for the least common multiple. But it's the same idea. So we're going to set up for our table method. We will set it up the same way we did for those factors. My goodness, I don't like how this is so slow for the erasing. All right. So we still have that 6 and 10. So we're going to make our table. We're going to pull out a factor that they both share. So what number can I divide down by? Clara.
2.
2. 6 divided by 2 is 3. 10 divided by 2 is 5. Can I pull anything else out? No. So when we did greatest common factor, we just took what was on the left side and we multiplied together. For least common multiple, we make an L. And we multiply any of those numbers that we take out plus the numbers at the bottom of our table. So we would multiply 2 times 3 is 6. 6 times 5 is 30. So we get the same answer, and we didn't have to write as much as we did when we were writing out all of those multiples. So let's try it again. Let's try it with 15 and 21. What can I divide out of 15 and 21? Ellen?
3.
3. 15 divided by 3 is 5. 21 divided by 3 is 7. Can I take anything else out of the 5 and 7? Nope. So what am I going to do? Both.
Multiply 3 times 5, and then multiply the answer of that by 7.
So I only took out the 3, so I don't have a number above it to multiply. Well, I'm just multiplying by the bottom now. 3 times 5 times 7. When I multiply all 3 of those numbers together, I get 105. Let's do our listing method, because it says to do it for both methods. So who can skip count by 15 for me? Colton.
15, 30, 45, 60, 75, 90, 105, 120, 135.
Okay, we're going to stop there because I'm running out of room. Now let's skip count by 21. Colton.
21, 41.
Oh.
Wait, 21, 42, 63, 84, 106, 127, 159, 180.
Let's look at that. Do we have any in common? What did you notice, Finley?
That 106 should be 105.
106, we were going 1, 2, 3, 4. That should have been 105. It's that easy to make those simple mistakes. That's why when we're using those big numbers to skip count by, it's not as easy as we make those simple mistakes. It happens. So I'm kind of glad you made it because it's proven my point. That was perfect, Colton. So, yeah, they do share that 105, but when he was listing them, he wouldn't have found it because he made a simple skip counting mistake. It happens. That's why we don't always want to rely on the skip counting method to find what that least common multiple is. Let's see what we do when we have 3 numbers. This is where it's going to be a lot different than when we did our factors. All right, so we have 9, 15, and 18. Oh, can't go off the page this way. What can I take out of 9, 15, and 18? Laura?
3.
I can divide out of 3. 9 divided by 3 is 3. 15 divided by 3 is 5. 18 divided by 3 is 6. Now here's where it's different. When we did greatest common factor, if I couldn't take the factor out of all 3 numbers, I stopped. This time, if you can take it out of 2 numbers, we take it out. So what is a number I could divide out of 3, 5, and 6? Of at least 2 of them. Joe?
3.
I can divide a 3 out. 3 divided by 3 is 1. I can't divide it out of the 5, so I'm just going to bring that 5 down. 6 divided by 3 is 2. Is there another factor that I could divide out of 1, 5, and 2? 1 is not going to make a difference because 1 times 1 is going to be 1.
What about 2?
So 1 times 5, 1 times 2, it's not going to change the numbers, right? So now, what am I going to do to find my least common multiple? Clara?
You can multiply each number.
I multiply all the ones that I pulled out, so I'm making that L, and all the ones on the bottom row. So what I pulled out and on the bottom. So now we can see it's more of an L shape because I had to pull out more numbers. So I'm multiplying all those numbers that are in the L. So 3 times 3 is 9. 9 times 1 is 9. 9 times 5 is 45. 45 times 2,
90.
90. So now let's see, using the skip counting method. So I've got 9. Oh, I can skip count by 9s. Those facts I know easy. So 9, 18, 27, 36, 45, 54, 63, 72, 81, 90. Now I'm going to skip count by 15s. 15s I can do, those skipping by 5s. So 15, 30, 45, 60, 75, 90, 105, 120. Skip counting by 18 is a little trickier for me. So you guys are going to help me out. I know 18, 36, What's 36 plus 18, what?
54.
54, what is it?
72.
Keep going for me, 90?
Oh, 108.
Give me one more.
126.
Thank you. All right. What numbers do they all have in common? Grace? So I still find that least common multiple of 90. The 9 and the 15, I was able to do my skip counting at 18. That's when we start making those simple mistakes like we had with 15 and 20. Like when you get those bigger numbers, it's easier to make a mistake. Takes more time because you're having to really think through what numbers to list. We get the same answer. Okay. You can use either method. If you say, oh, Ms. Gambino, this just makes sense to me. This does not. I want to do it this way. Totally fine. Okay. Use the method that works for you. Just make sure you're not making those simple mistakes. Using the table method, you have to remember that this time we can take out of just 2 of the numbers. It doesn't have to be all 3. And you multiply on the left and the bottom. Finley?
Can we use our calculators to multiply it?
Yes. So let's look at our word page. So, yes.
On the test, can we just use our calculators?
I have to look at the test. That's a great question. Joe's question was, on the test next week, can we use our calculator for some? Are there any that we can't use the calculator? I'm gonna go back and look at the test. I have to print them all. So I'll have an answer for you tomorrow.
Can we use a book?
Another great question. He said, can we use our book? You can't use the book because that's your notes. What can you use on the test?
Help sheet?
Help sheet. Okay, so like we used the help sheet for the entrance exam and we wrote key things from each objective to help us. You can do that again next week for the Unit 1 test. So you can't do examples, right? So when we have that least common multiple and you want to say do the table method, you can't put numbers in and have examples, but you'll be able to do like on the help sheet, you could do like this with no numbers in there. But would that help you remember what you have to do? Yeah. So you could do something like that, but you can't actually fill it in with numbers because you can't have examples. Cameron?
Can you like, so for the numbers, can you put like letters instead, reminding you can put numbers in like that?
Sure. All right, so let's look at least common multiple, show your work. Either method, whichever one you want to use. I don't want us to look at 3 and 8 and say, I can do mental math with it. I know what it is. Because this is homework, I want you practicing. Because we will get to bigger numbers that we don't know off of the top of our head. So even though it's easy, at least this one is for me, I know what the least common multiple is just looking at it. I want you to practice. So because I know that we know how to list the multiples to see that least common multiple, I'm going to give an example of the table method. So if we had the 3 and the 8, what can I divide out of 3 and 8? Is there a factor I can divide out? So what do you think I should do?
I don't know.
Bo?
1?
Well, if I divide a 1 out, then it's going to be 3 divided by 1, 8 divided by 1. Now do we know what to do? Cameron? Yeah. Remember, we make our L. So did I actually have to divide the 1 out? No. But it helps us see what step to do, right? So what is our least common multiple? Finley? 24. I like to circle my final answer, and I like it when friends do that on their tests, because then I don't have a hard time figuring it out, because sometimes we get numbers all over the place, and a couple of us, we found when I've corrected practice works, I get lost trying to follow all of your numbers and your work, and I mark something wrong, and somebody's like, but I have the correct answer right here, and I couldn't find the correct answer, because it got lost in the work. So circle that correct answer so I know where to look. So get in the habit on your homework circling it so we can do that on the test. Finley?
Could you also do it with 2? Because I did it with 2 and then it's still 24. But I just
What do you
wrote
mean
down
do it
the
with 2?
Like divide it with 2.
Can we
Because then I just brought down the 3. And it was still.
So the thing with that is you're doing more work than you need to do, because if you're taking a factor out of 8 and not out of a different number, I mean, it works,
Yeah.
but you're doing extra work.
Oh, okay.
Does that make sense?
Yeah.
All right, do you guys understand how to do this page?
Yeah.
All right, so let's look at our next page. You have another work page, right? All right, word problems. Just like with the greatest common factor, when we have the word problems, it's the same math. Okay, it's not that many. It's not that many, friends. So let's look at the first one. Pat, Mark, and Chris take off from the starting line on a racetrack at the same time. Pat can run a lap in 2 minutes, Mark can run a lap in 5 minutes, and Chris can run a lap in 7 minutes. How long will it be until they are all together at the starting line of the track once again? What numbers do you think I should put into my table? Clara?
2, 5, and 7.
2, 5, and 7. What number can I divide out of all of some of those numbers? Elliot? Yeah, just the one. The only factor that I could divide out would be that one. And I multiply them together. 1 times 2 is 2, 2 times 5 is 10, 10 times 7 is 70. 70 what? Ellie?
Minute.
Minutes. Now I need to look, and what is my question? How long will it be until they are all together at the starting line of the track once again? In 70 minutes. That actually answers my question. I am going to give you a heads up. Sometimes what you come up with here, you need to do a second step. Sometimes if they said, Pat, Mark, and Chris take off running from the starting line on the racetrack at 11 a.m., at what time will they all be back again? And you say 70 minutes, well, that's not answering the question. The question was at what time, so we would have to take that 70 minutes and add it to the time they started. So always go back when you are looking at your questions, like down here. I see at what time will the stoplights again turn green together? So you might have to do a second step once you find the least common multiple. Check to see if you have to do a second step to it. Elliot?
Could you put an hour and 10 minutes?
You could put an hour and 10 minutes. It means the same thing, it's the same value. I would take them both. Joe, do you have a question? Or you just, yeah, what's your question?
Since is Pat currently running continuous laps until they beat the track again? Because if they start, it takes him 2 minutes, and then 3 minutes later, Mark will be there, and then Chris will be there 2 minutes later.
If they keep running until they all end up at that starting line at the same time. So in 70 minutes. Okay, so yeah. Any other questions? So if we look at the bottom of the page, there is a review question at the very bottom. Remember, you can look back at previous objectives to answer that question. That's helping us remember what we did at the beginning of the unit, because the test is next week and we need to remember it all. If you are watching this at home, I hope you are well. I hope to see you soon. I hope you have a wonderful day. Don't forget to like and subscribe. Remembering today is a Thursday. So when you get finished with your assignment, check to see if you have Blackbaud done. Check to see if you have Khan Academy done. That's due tonight. Work on packet number 1. That's due on Tuesday. Okay, so once you finish the assignment, work on your other math homework. Have a wonderful day.